exponent because it's lower, so what do you call that?
Which part?
On that one equation for figuring out the confidence interval, it's like EA over 2. What do you even call it when it's not raised? It's like below.
So what question are you on?
I guess I'm on part 2, number 3. When you have to figure out the confidence interval. Do we want to start before that? Am I getting ahead?
No,
Is that where the questions start for you guys, or do you want to go?
I've got questions on part 2.
Okay.
Okay.
Is that where y'all are at too?
Let's start with part 2 then.
Okay.
So which number did you say? Number 3?
Yeah. Well, I didn't look up 1 either. The requirements for creating a 95% confidence T interval. Number 1 on part 2.
So is this what we did through that SPSS program?
Well, it had us try and figure it out ourselves first, and then do it on the SPSS.
Oh, okay. Because it's like on the SPSS, I know how to do that.
Yeah. Me too. That was pretty straightforward, but trying to figure it out by hand. Is that the answer key you've got up on the other side there?
So this, if you look at my screen, Tara, this is what I have. This is my prep assignment.
Those are your answers?
Yeah. So like on the right side is the textbook.
Uh-huh.
And so this is what you're looking for, is the confidence interval. And so X bar is 46.73, and we got that from up here, the last question.
Uh-huh.
And then the T, they give that to us, which is 2.1448. And then the S, which is the standard deviation of the sample.
How come I put 2.9? I put 2.9. Why would I have done that?
I don't know, where'd you get 2.9?
It's over here for the 14 degrees of freedom.
Oh, on number 3?
Uh-huh.
Oh, that's why. Well, yeah, 2.9 goes on number 3.
You're on 2.
Oh, you're on number 3. Okay. Yeah, same thing. So yeah, it's 2.9768, and then the standard deviation is what you should have gotten from the software, and then square root of 15, which we got from the story. You randomly selected 15 clients, and then you just compute it, and then same thing, but addition instead of subtraction.
No, I guess so. The formula that I got for that was a little screwier.
What formula did you use?
So it was X bar minus PA over 2 lowered. What? I don't know what that means. Times S over the square root of N. Huh?
Where did you get that one?
I got that from Brother Balls' presentation.
Oh.
I haven't watched that one.
Maybe it's a good thing I don't watch them.
Well, they're pretty straightforward, except for that little doohickey.
You understand this is recorded, right?
That's true.
I don't think I should be saying things like Kuda Wada and don't watch Brother Balls' presentation.
Well, I really can't, and then when I have the time to, I either get too lazy or I just forget, and then I'm like, oh darn it, oh well.
Yeah.
Anyways,
it was like it was super good because it was way quicker than trying to figure out through all the written stuff. It was really helpful.
yeah, what I do is I always watch the instructional videos before I even read the book.
Yeah.
Really? That's funny.
Of course, that's when I read it.
That's what I do too.
I'm the only weird one that doesn't watch the videos.
So what we're really saying is that whole T over T A over 2 or whatever that is, that really is just equal to T or T star.
Yeah.
I think that's what.
Mm-hmm.
Well, so the same formula that David uses is the one that I use.
Okay.
Kind of like the same formula that we did on Tuesday, except for the Z is the T,
Yeah.
Okay.
or the T is whatever. It replaces the.
Okay.
Mm-hmm.
All right. Then I think I'm okay. Then I think that's what I was up.
So, did anybody know how to figure out the same answer but using SPSS? Oh wait, you have to use SPSS. Does anybody know how to do that? Because I was trying to figure that out. I really wasn't sure what I was doing.
A different confidence level.
Yeah.
Yeah. Here, I'll do screen share. Let's see.
Yeah, the little videos really outlined how to do that really clearly too. That was
All right.
Oh,
so
really?
really simplified that.
You see the SPSS on here?
Your screen's not sharing.
No, it's not. Let me take a look here. Oh, I didn't click the actual thing.
This is very easy. So actually, we don't but that's maybe years later.
There, can you see it now?
Yep.
Okay. So for this one, like when you do a confidence interval, let me. You go to the analyze, of course, then you go to the descriptive text and go to explore. And statistics, it has a confident enter the levels right here. You just change that to 99%.
Okay.
99%. You put in other plots that you might want to do, and then you hit OK. And then so now, let's see. So now it's going to be at a 95% level. It is at a 99% level. And that will give you.
What's the answer you're looking for? Or like what value are you looking for that'll give you the answer?
Basically just inputting or finding that right place.
Yeah.
Oh, you mean like it doesn't actually give you the answer, it just gives you the mean and the standard deviation and all that, and then you have to put it into the formula?
No, it will give it to you.
It will give you the
That
answer.
gives it to you.
Okay.
Just the normality.
Like,
So now this is what is totally so it's just
Somewhere in here.
Maybe you might have hit the wrong one.
Is it the one where you go to analyze and compare means? And then you click on one sample t-test?
Yes.
yes.
Okay.
Yeah.
Okay. So go to compare means, one sample t-test, And then down at the test value, what gets put there?
For the test value
Is that 47?
for it's the value for the null hypothesis.
Okay, so it is 47.
Right.
Yes.
Okay, so then you press OK. Okay. So then,
Like the one sample statistics will come up. But it gives you the confidence interval down there, but he said not to use that one. You need to use a different process to get the confidence that's accurate.
so what exactly do you do? What exactly do you do then?
So to get the confidence interval, you have to go to Analyze, Descriptive Statistics, and Explore. And then you throw the data over, and then you click on Statistics, check Descriptives, and you have to set the confidence interval.
Okay, and that's all in the little videos?
Yeah. Yeah, he gives pretty good steps. And that, I mean, that covers it. Then you click Continue and click OK, and then it'll spit out a more accurate confidence interval. Although it's the same. No, it isn't. Just kidding, it's not the same.
I think I'll just watch the video then. I have no idea.
Yeah. Yeah, I mean, that's really the steps. Just Analyze, Descriptive Statistics, Explore.
Okay.
Then, throw over your data, click Statistics, check Descriptives, set your confidence level, and continue.
Okay. So then, can we go over D real quick on sketching the area for p-value?
Yeah, this is the last part I needed to do.
E? What number is that under?
What's that?
What number is that one under?
Number 6.
Okay.
I needed to go over B too.
B under number 6?
Yeah, I was kind of stuck up at B because I felt like I wasn't sure how to do it without having the confidence level. Were you guys able to didn't we need the confidence level to be able to do that? Maybe it's because I wanted to do it in SRSS, and if I did it by hand, it would be okay.
Maybe. I don't know. I just know that that's the formula that's given in the textbook.
Mm-hmm.
Is this one that I'm sharing?
Yeah. Did you guys compute that by hand?
Yeah.
Do it and catch up with you then.
Okay.
Pull back up your little chart thing there. Get it right. You're supposed to need the D. You're supposed to have shaded in the tails for the T distribution.
Wait, what's that?
So that website you had up with the T distribution?
This one?
Yeah. So you have it right because you shaded the tails on it. That's what you're supposed to do. That's what it's asking.
And that's the p-value?
So,
And then, go ahead.
we'll scroll down to D. So yeah, it says sketch. Or let's see here. Do you sketch the T distribution, shade the area with that represents the P value, and the P value is that to shade both of the tails. That gives you that represents the P value. And so that's basically what it's just asking. You just say you shade the tails.
I can't remember very well why it's the tails and not the middle. Do you know why?
That would be in a previous lesson.
Yeah.
It's the tails because we're looking for the difference between.
Oh, that's right. That's right.
So we're looking for both sides.
If it has to do with when you set up the hypothesis, is it a two-tailed or right-tailed or
If we're
left-tailed?
looking for greater, then we would shade one side. If we were looking for less, we would shade the other side.
Okay. Okay, and then down here on the T part, is that oh, I didn't. That's okay. That's the answer that we got from B, right?
So speaking of the answer from B, I got T equals negative 0.117012.801. Is that what you guys got?
Yeah, I got that too.
Okay.
T equals negative 0.118. Is that what you said?
Yeah.
No.
That's what I got.
Oh.
Yeah, I got negative 0.118.
Yeah, that's what I got as well. So then that goes on here.
Yeah, so I put 46.73 minus 47 over 8.83 divided by the square root of 15.
Oh, well, I left my decimals long.
Oh, okay.
So, okay. Did they warn against rounding?
Yeah, they did. Somewhere.
I would keep the decimals longer rather than rounding them till the very end. So did anybody check it with the software? Did it match?
Oh, I didn't. I didn't know how.
Okay.
I tried following along with the textbook, but I didn't really understand it.
Yeah.
The SPSS says negative 0.117.
Okay.
So then they probably rounded it up is what it was.
Well, it didn't round it up early on. Like if you round before the end answer, like that 8.82745 needs to stay out long and not round that, or your answer will come up short.
On what number? Or to what letter?
Well, when you're figuring out B,
Oh, okay.
I would not round that 8.82745 over the square root of 15.
Oh, gotcha.
Or you'll come up a little off.
But what I don't get is, so like I'm pulling up the answer document right now, and in the answer document it also rounded up that 8.82 to 8.83.
Really?
Yeah, so that's what confused me, because I did it without rounding it, and then I did it with rounding it, because I was like, I always double check what I did to the answer document.
Right.
And so I saw that they rounded it up, so I changed it and rounded it up, and that's why I got the negative 0.118.
Huh.
That's what I did too.
But if SPSS doesn't do it, then why should we?
Yeah, that's what confuses me most, is about when to round and when not to round, because I read different things. They're like, you're supposed to round this, and you're not supposed to round till the very end. And I don't know what rule they're trying to apply what.
Right?
It's weird.
Where's that TA? He needs to explain this ambiguity for us.
Hey, aren't our office hours about now?
Yeah.
They are.
Yeah.
Well,
They
you put
are. Yeah.
the email. Let's see. Um, Megan Willard. Yeah, her office hours are today's what, Thursday?
Yeah.
Okay, they're not till 1 to 2.
Well, maybe we could shoot her a note now and she'll get it in a while. So, the C on here is talking about stating degrees of freedom.
Uh-huh.
And I didn't really understand what degrees of freedom were. You guys get that?
Me neither.
See any explanation for what that was at all?
Alright.
The only thing I got from watching the videos, the tutorials, was that it's the sample size -1. So, like in this case, since their sample size is 15, the degrees of freedom are 14.
Well, what the heck does that mean?
That I don't know.
Yeah, me neither.
Okay.
I'm
Well,
not even
I'm
gonna try either. No, I don't think you missed anything.
Okay. I can just accept it's unknown. That's like kind of my mantra. Just accept it.
You know how to figure it out, then we're good.
Yeah.
The degrees of freedom has to deal with the t distribution, right?
Yeah.
It's basically saying the higher the number, the more that the t distribution is going to match the bell curve. So the higher the number, the more likely it's going to be in line with the bell curve, whereas the smaller it is, the more off it's going to be, or whatever.
Okay. Well, I remember that part. I didn't remember that had to do with degrees of freedom.
Yeah, like,
The higher the number, the more it will match the bell curve.
Yeah, so
Okay.
So here's the section in the textbook that I was looking at for that. So it shows the t distribution, and then it shows the degrees of freedom, which is the red line.
Uh-huh.
And so the larger that number gets, the closer it mirrors the normal distribution.
Okay. All right.
Anyways.
That's degrees of freedom. Okay. So, degrees of freedom on SRSS is this little DF over here, right?
Yeah.
Yep.
Yes.
So it's 14.
Yep.
Yes.
Shade the p-value. Did I get p-value in my... I'm finding the p-value in the software is...
I remember the p-value is when you have both tails shaded and the middle clear.
Okay.
And on the software, when you look, it's the little box that says like sig two-tailed right next to the degrees of freedom where it says 0.909.
Well, mine says 0. I must have done...
Did you put 47 as the... That's false.
Maybe I didn't fill in the test value or something. If I go back and I go analyze, do I do the compare means one for this, or descriptive? I do the compare means, right?
Yeah.
Compare means, unsample t-test. Okay. Then you put in the confidence interval. Right?
The test value, you put in the test value is 47.
Where do I find
And the
test value?
confidence interval is 95, right?
Because I'm on the one sample t-test, and I go to options, and it just gives me confidence interval.
Yeah, go back to where it says like test variable before you push options.
Oh, there, test
There's a
value.
little box,
The box. Okay.
and you type in 47.
Okay. All right. That did it. So it's 0.909.
Yes.
Okay. Super. So we accept the null hypothesis, or we failed to reject the null hypothesis.
Yep.
Okay.
Because the P is higher than 0.05.
Okay. And that sounded like English to me. So that's the end
Yeah,
of
when it asks for the English sentence to put it in English terms or whatever, I
Uh-huh.
remember in the textbook it said if it's reject the null, then it's because they have insufficient evidence. But if it does reject the null, then it's because they have sufficient evidence.
Okay. I can remember that.
Okay.
So,
Shall we start our quiz?
Yep.
let's.
Yes.
Is everyone ready?
I am.
Yep.
Okay. I'll start. In previous lessons, we have assumed the population standard deviation, sigma, was known. In this lesson, we are making a different assumption about sigma. What has...
Okay, I'll do the next one. The null hypothesis is the mean equals 8, and the alternative hypothesis is the mean is greater than 8. And the population standard deviation sigma is not known. Becca collects a sample size n equals 9 and computes x bar is 11 and s is 6. And s is the sample mean, right?
standard deviation.
Standard, okay, right. The sample. Sample standard deviation. Okay. This information for questions 4 through 5 is known. Yes, I got the easy one. No. Y'all take the rest of the stuff. I'll take no. Sigma's not known.
Okay, so
What is the value of t?
Okay, so gotta plug it in, huh?
Value of t. So that's, I believe, this one.
Yeah, T is the critical value, right?
The test statistic, right?
So
Do we have to use that formula? T equals x bar minus.
That's what I'm thinking.
Okay.
yeah,
Equals x bar minus mu over the sample size divided by the square root of n.
Yep.
Yes.
No. X bar's 11. Mu is
8.
8.
S is 6.
And it's
And
9.
9.
If there was no interest, why did 3 years? So this is all my rest. Maybe we can have 5.
I got 1.5.
Me too.
That's what I got.
Yeah. So it's just 1.5, and it says round to 1 decimal point.
Yep.
Look at this.
We're good.
Now we get to put some junk into SPSS.
So you can get the data from the book. There's a link for it,
Oh, okay.
and you can upload it directly from. It'll automatically load.
Where do you get the data?
So if you go to lesson 11 in the book, it will have a link for body temperature. Let me find where it's at. Okay. So
Yeah.
there. That's alright. So you should see my screen now. It shows where that's at. So it's right here, body temperature.
Ah, there
If
it
you click
is.
that link, it will take you to the data page. Scroll down. The first files. Oh, okay, here you go. And then you just find body temperature. You click on that, and it will open up the SPS file that you need.
Isn't there a data file in SPSS that has all of our stuff? Or is there not? Didn't you show me that one, Sammy?
I don't know if there is or not.
Search data files. I don't know for sure. I'm going to go back and open up.
Alright, so using the following values, which are filed under the body type. Copy and paste image in software, assign the use, Using the null hypothesis equals 98.6 in the alternative, which is the mean is less than 98%, or 98.6, and the level of significance is 0.05. So what is X? Round to the nearest 3 decimal place.
So, is this where we go to analyze descriptive statistics, or is that for the whole thing?
Analyze statistics, explore statistics.
Body temperature.
I guess I have to log into iLearn and everything to look.
What is X? Round to the nearest. So X is the, what is that? The sample mean. So I got 98.234.
That's what I've got here too.
So that would be the very bottom one, 98.2. So now we're on 7.
Okay, wait, what was X?
It's 98. Okay, so here I'll pull up my. I'll share my screen. Let's see. Okay, you guys can see my screen now, right?
Yeah.
Yep.
So this is the SPS data. If you look for the mean, it's right here.
Okay.
That gives you the 98.234 because X is the standard or the sample mean, and so that's what that is.
Okay.
So S is the sample standard deviation, right? So we would just use the same. We just find where the standard deviation is on this.
Yep. 0.738.
I have 0.7376.
Right. And then just round it.
Oh yeah. Pink computing.
And then the next part we have to compute, right? Because I don't know if this thing gives us the t-score.
So the t-score.
Or is
Isn't that the is that where you do the formula S divided by the square root of n equals margin of error? Is that
yeah. Right.
okay? So then we take S, which is that number we just put in, 0.738. And we divide that by the square root of n, which is, let's see, n is the sample size, so what was the sample size?
Sample size. It doesn't really tell us. Oh, well, I guess these numbers, right?
Yeah, it's how many are in the
20. I counted 20.
okay, let me just see if I can find an SPSS though too. Without, like,
I wonder if, because in SPSS it's 148, but these numbers that we have right here are only 20. So do we just manually find the mean? Or I guess manually put it in the...
so yeah, and it says 148.
So are we only supposed to put in ones that are on the quiz instead of doing the...
Yeah, I think so.
Well, I mean, if you're looking at the graph too, it does go down 148. So I think that would be the sample size. Because it's telling us to use the data from
From the data file.
Well, it said that it was pulled from it.
Are you guys on the baby boom one now?
No, the body temperature.
Still on the body temper?
Yeah.
On which number?
We're on number 8.
5, 6, yeah, or yeah, 8.
8. T-score?
So I guess what we can do with that is one of us will do the 148, Someone else could do the 20, I guess.
If we only use these 20, then that's going to change the number for our 6 and 7 too.
Well, no, because we're still using the data file from SPSS.
Yeah, but this says to copy and paste the ones from this one onto SPSS. So I don't think we're supposed to use that whole data file.
So, okay, the following were pulled from the body temp thing. Copy and paste
Oh.
software. It's fine.
The data file's much bigger than that, huh?
Yeah.
There's 140
Oh.
years.
So we do just have to plug those numbers in. Copy and paste them into the software. Okie doke.
Okay, so I've got something else. If you want to look at my screen.
I can't believe how many screens I'm bouncing between.
Yeah.
I know, right?
Okay, I'm looking at your screen.
So the mean is just slightly changed to 98.22, and then the standard deviation is 0.92201, and that's the 20 numbers that I plugged in.
So then that's the sample standard deviation, so that's S.
So we changed those in, huh? Good thing we caught that, or good thing you caught that.
Yeah.
Yeah, good job, Amy.
No, thanks.
So that's 220. And then
Sorry. So T score is
so we gotta change this number around.
So it's 8.22.
I got 0.206.
the T score.
And that's using the S divided by square root of n is the
Oh,
margin.
we've got to do the formula. It doesn't give it to us on SPSS.
I don't know. I don't know how that works.
Yeah.
Well, I don't see anything on there that says T-score.
Well, let's see. If you go to analyze, compare means one sample T, then it gives us down here T, but I don't know if you're supposed to do something else, and that's
Okay.
What did you say you got? 2 point what?
When I divided it by the square root of 20, I got 0.206.
Okay, what formula are we using?
Well, I thought we were looking for this T. Because in the book it says T. If we're looking for the margin of error,
No, we're looking for the T-score. So that's the X bar minus
the mu.
mu divided by the sample standard deviation divided by the square root of the
Sample size.
sample size.
okay.
What is that sample size?
20.
20?
It was 20, I thought.
Okay. And the mu is the 98.6.
Yeah.
I'm sorry, what did you guys get? Negative 1.843?
I've got. Oh, I
No?
have to divide. Just a second.
I got
I
negative
didn't do that at all.
446. Which, if we're rounding to 3 decimal places, it would be 845.
Yeah, that was a negative, right?
Yeah, I got a negative.
I mean, that looks like, yeah, that looks right to me.
Negative 2.910. What you guys had?
I got negative 1.843.
Oh.
I got negative 1.845.
Oh. Well, what did I do? So the top number, 98 minus 98.6 is negative 0.6.
Isn't it 98.220?
Yeah.
Oh, did I put the wrong number in?
Yeah.
So what did I do?
So it's 98
Oh.
minus 98.220.
Okay. Because our S is 98.220?
No.
That's 0.922.
Yeah, S
Okay.
is 0.922.
And then N is 20.
Okay. I feel like I'm going crazy right now.
That's what this class does to me.
So it should be 98.220 minus 90 minus 98.6.
Yes.
98 minus 89. 98 minus negative 0.38 divided by, so you guys don't figure it out. Okay, so now I've got negative 1.843. Is that right?
Negative what?
Negative 1.843.
That's what I got.
Okay. All right.
But Amy got a negative 1.845.
Huh.
I'm doing it over just to double check.
Okay, so when I left my numbers long, then I got negative 1.843.
Okay. Then let's go with that. So now p-value, that's back to last week, isn't it? Or is that, does that come up in the
Yeah, use the applet.
applet? Because it's
Yeah,
the area. It's like the percentage, right?
Yeah, we put that t-score in,
Uh-huh.
and the t-score was what? Negative 1.853.
Into the applet, huh?
And then we shade both cells, and that gives us the score 0.1609.
0.109.
0.1609. That's right, guys. I'm starting to question myself.
Good.
So we're just shading to the left, right?
Oh yeah, because we're trying to see if it's
We're trying to see if the mean is less than 98.
so then we shade. Yeah, we shade to the left. So what are you guys getting?
I got 0.0327.
For what again?
Or the area.
So if you put in negative 1.853, and then you just shade the left tail, right?
Uh-huh.
I'm getting 0.0805 for
Did
the
you
area.
put in 0.853, did you say?
Oh wait, what's the
43.
degree? What's the degree of freedom?
I have no idea.
It would be 19.
What?
19?
Because it's 1 minus our sample size. So our sample size is 20, so the degrees of freedom is 19.
Oh,
Okay,
that's
yeah.
right.
So that gives me
Oh, good job, Amy.
0.0397.
Wait, what does it give you?
0.0397.
And you put in what again?
So if you have the t-score is negative 1.853,
Oh, 1.
you have the degrees of freedom is 19, and just shade the left tail, that will give you the 0.0397 for the area.
You mean 853 or 843?
Yeah, I have 4.3. I have 8.43.
I have 4.3.
Oh, maybe I just mistyped.
Okay.
Okay, so that gives me a different thing.
Okay. So then do you get 0.037?
I got 0405.
That's what I got.
We're shading to the left of the negative t-score?
Yeah. Yes. Because it's less than. The alternative hypothesis is stating that it's less than the mean. Which would be the left tail.
Are you using a different applet than I am?
Yes, you should be using the one that's on my screen.
Where did you find that one?
I got this one from the textbook.
Yeah, that's what I'm using too.
Oh.
You put in the degree, so it's what Amy said, the negative or n minus 1, so it's
Which is
19.
19. Mm-hmm.
And then you put in the t is negative 1.843, and then that gives you the area of.
Okay. So 0.0405.
Yep, 0.0405. Yep.
Well, we're only supposed to round 3 decimal places.
So it'll be 041. Yeah.
I don't like this chapter.
For 10, because it's less than 0.05, then we would what was it?
If the P is low, reject the null.
That's reject it.
That little catchy phrase doesn't leave my mind anymore.
I know, right?
It's low, reject the null. Okay. I'll have to remember that. I was looking at on my notes.
Oh man, another one of these.
Holy crap, I thought one was enough.
Apparently not.
Oh man.
Okay, so we have to cut and paste this in. Or copy and paste it in.
Oh yeah, can I do that?
So this one, there's another data file for baby booms.
But we'll run into the same problem.
Oh yeah. I guess
We've got to copy
Okay.
and paste it.
I'm putting it in right now. Okay, so that's what we got out of the numbers that I just copied and pasted. The mean, it says that it's 40.0476, and the standard deviation is 36.35, and a bunch of other numbers.
Okay, hold on. Oh gosh. 40 is the... I'm starting to twitch. This is just... I don't think I should drive after this.
It's a terrible drug.
And the sample size is 1, 2, 3.
Oh yeah, how many? It's
21.
yeah, 21.
The
Okay.
P... I can't see you and see this at the same time, so I'm...
Oh, wait, what is it? Sorry.
Okay, so you figured out with this that... Can we get the p-value from it, or just did you get the mean and then we have to do the whole equation?
Oh yeah. Okay, so this asks for different stuff, but we still have to compute the same thing.
Yeah,
So
we've got to pull the data from this, right?
yeah, so we have to figure out what the t-score is out of the mean and the standard deviation that I just plugged in,
Okay.
and then that will give us the p-value. So once again, t-score, yay.
So you do the 40.0476 or 0.7, whatever, minus 40 over the standard deviation, which is 36355, divided by the 21.
Uh-huh.
21. Okay. So I got 39.806.
Okay, I'm looking it up right now.
So then this one, it would be, the degrees of freedom would be 20 because there's 21, it's n minus 1, so that's 20. And then we put... I don't think that's right.
That's weird.
Did you get the t-score as 0.006? Did anybody else get that? Or am I just going crazy?
I just cannot keep up.
We're here.
What equation are we doing? We're trying to find the t-score?
Yeah, because it's asking for the p-value.
Okay, so x is...
It's x bar is this thing right here, 40.0476.
Okay. And then the mean is 40, right?
Yeah.
Yep.
Okay, so then S is that 36.35585?
Yep.
And the sample size is 21?
Yep.
Okay.
I don't know why I'm getting something totally different. I get 39.8068.
Oh.
That's like way off.
Get this right. So so we're doing 40.0476 minus
Okay, I see what I did. I typed in the calculator wrong.
40.
What did you get, David?
I got something weird. I got 0.006. I don't know if that's true or not.
That's what I got when I typed
got.
it right.
Oh, okay. How are you doing, Tara? Are you hanging in there?
I'm way behind. You guys just go on ahead.
Where are you?
I'm Kansas, I think, somewhere left at Albuquerque.
You're far from home.
Way too far from home. It's Oz, actually. I went back and put my numbers into SPSS on my own because I couldn't keep up with your charts. So I'm just finding. That's all right. I'm just finding the mean right now. So you guys just go on ahead. Oh.
So then, Dustin and Amy, you both got 0.006?
Yeah.
Okay.
Oh, you know what that is? That's here in the SPSS stuff. The t-score is there.
What? Where?
Where it says one sample test. There's the DF, there's a T, a DF, and the two-tailed.
And it says 0.006?
It says 0.006, yeah.
Oh, hold
Look,
on.
we did it right. That's amazing. I'm so proud of us.
Does it tell us the answer to the next question, is the question.
What did you
What's
put
the
under
next
the
one?
test value, Tara?
I put 40.
40? Okay. Oh, sweet. It does tell you this. Okay. Now we
So
know.
then what's the p-value?
Oh,
the-
that one. Does that tell us too?
I think it does. I think that's what the two-tailed thing is.
Well, let's find out. What is this? What does the thing say?
Well, is our hypothesis a two-tailed answer?
No.
No. What is it?
Oh, wait.
Your alternative hypothesis is that it's not 40.
Not. Yeah, it is a two-tailed.
So it
Yeah.
is a two-tailed. So I think that's it.
So
it's
what do you got?
995?
0.995. Yeah.
Okay.
Huh.
Because when okay, 9.995.
So if you put it into your little applet thingy-majigger that I have yet to find.
It gives me an area of 1, though.
Yeah, same here.
Area of 1.
Yep.
Well, that would be everything. That would be 100%. Is your shading must be.
Well, there's...
Did you do the...
Did you just highlight the tails?
Yeah. Okay, I'll show you what it looks like. It's kind of weird. Let's see. I have so many windows open. Where are you?
Which might be close because 0.995, if you round that up, would be 1.
Yeah, David has it up there.
See that.
Can you see it?
Uh-huh.
Yeah, because there's 21 samples, and you minus 1, so that gives you 20 degrees of freedom. And then, so are we supposed to round up the p-score then and just put 1? It says round to 3 decimal places, so
I guess we'll go with 0.995.
yeah, that gives us the 3 decimal places. So, and
Didn't
using
find
a
that
level,
off of our thing.
okay.
Headache.
But it says we're using a level of significance of 0.01.
Yep. And so when it says what decision do you make, so since the P is higher than that, then we failed to reject it.
Gotcha.
Are you with us, Tara?
No, my kindergartner's bus is here right now. I have to go.
Okay.
So, good luck, guys.
Okay. Bye.
Bye.
Yeah. Okay. So. 13 then?
So now it says, wait, so are we all on board?
Yeah.
Okay.
Yeah.
Okay, so it says you decide to try another alternative hypothesis. This time you use that the alternative hypothesis is less than 40. You keep the same level of significance. Did the p-value increase or decrease? So
Yeah.
right here would be just the left side, right?
Yeah, just be left side and so it decrease. Because it's
So,
now at 50 point, or it's 0.5024.
Okay. And so then that means, okay, yeah, so it decreases.
And then it's still greater than 0.01 though.
Yep. So then we would still fail to reject no.
Yeah.
And then the last problem says compare the width. Sorry?
50, right? The p-value decrease.
Yeah.
Yeah.
Okay. All right.
So 14 we would fail to reject the null because it's still greater than the 0.01.
Right.
And then 13 we need to compare the confidence interval for questions 11 to the confidence interval of 13. Which one is wider?
Oh, are you kidding me?
So we have to figure out the confidence intervals.
So for 11 and 13.
11.
Oh,
that's so much work.
I have the confidence interval formula right here.
Yeah. I think it's
It's that x bar minus z times
minus t.
Over the square root of n, right?
Yeah.
And then you do the exact same thing, only you add it.
Yeah.
Yes.
Ugh.
My sentiments exactly.
I wish there was an applet for that.
Right.
All right, so let's start plugging in numbers. What is the x?
But can we just find the what? Oh, do we know what confident?
Oh yeah.
Because
Yeah. Right here.
no.
Right? For 95%. Is
Are
it
we
95?
looking for 95%?
Oh, I guess it doesn't tell us, does it?
No, that's what I was.
Oh, darn it.
That would have been much easier. Okay, so we're computing.
Yeah.
Don't worry, it's the last one.
Oh, hooray!
Oh, man.
That's too much math.
Oh my goodness. What is Z? Z is the Z score, right? So,
T is the
so yeah, Z is 0.006.
yeah, that's the T. Yeah.
But isn't that also the Z?
Yes, pretty much.
Yeah, basically.
I'm just making sure. Then the standard deviation is 36.558. That's over the square root of 21. Alright, let's get this right.
Hold on. Wouldn't the answer be they are the same? Because I don't know what's different, other than that the hypothesis is, or I guess the alternative is less than 40.
Hold on. I think this is the one time I'm actually going to get a tuner.
Give me 1 sec.
Okay, there's somebody coming soon. What did you guys come up with? Oh, you guys are still computing.
Well, for the first one, I haven't done 13 yet.
But for 11, I got 39.999 and 40.095.
And then 40.095.
Uh-huh.
It's just good.
So they're not the same.
They're not the same?
Well, wait, well,
So for the other one, I don't know.
You know?
Oh, because in 13, the X bar is 40, right?
that car is 40.0476.
For both of them?
Yeah. I would think so, right?
Yeah.
So then how do we do it different for 30? You mean for 13?
13. That's what I'm saying. I think it's the same.
Because the only difference that we did was to find, I mean, the level of significance is the same.
Yeah, the only thing that's different is in 11 it says it's not equal to, and the other one says it's less. Mu is less than 40.
I'd say it's the same. I volunteer as tribute.
Yeah, I think so too.
Okay. All right. Here we go. You ready?
Yes.
I'm gonna submit. All right. Oh, sweet! It's correct.
Hooray!
Can I ask you a question?
No, we're good.
You're good?
Yeah.
Awesome. Thank you, though.
Awesome.
Oh, yay!
Okay, so good job.
Yes.
I'm going to stop the broadcast.